Okay, in this example, we're going to be expanding x plus 2 all to the power 5. As the power is relatively small, we can still use Pascal's triangle. So let's get started. The first term will be x to the power of 5. And the final term will be 2 to the power of 5. Pop that on at the end. In between, we're going to be using the binomial coefficients. We want the fifth row of Pascal's triangle, 0, 1, 2, 3, 4, 5. So the binomial coefficients we need are 1, 5, 10, 10, 5, 1. We've got the 1, so we want 5, 10, 10, 5, and we have 1 at the end already. Next, we'll put in our powers of x. We've got x to the 5, then we have x to the 4, and then x cubed, x squared, and x. Then we'll put in our powers of 2. So we have 2 to the 1, which is just 2. We have 2 squared. We have 2 cubed. And we have 2 to the power of 4. Now it's just a case of simplifying. We have 5 times 2, which gives us 10 x to the 4. We have 10 times 2 squared, so 10 times 4 is 40. And that's our x cubed term. We have 10 times 2 cubed, 10 times 8 is 80. And we have 5 times 2 to the 4, 2 to the 4 is 16, so 5 times 16 is also 80. And 2 to the power of 5 is 32. Before we move on, I'm just going to point out a way that you can check that you've written down this first line correctly. So notice that in every term, the powers add up to the original power. So the first term here has power 5. The second term has power 4, but this 2 has power 1, so 4 plus 1 is 5. The next term, we've got x cubed, and then we've got squared here. 3 plus 2 is 5. 2 plus 3 is 5. X to the 1 plus 4 is 5. And then 5 on the end. So it's a good idea to check each time you do this that for every term the powers add up to the original power here. Okay, here's a problem for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution. If you got it correct, well done, move on to the next example, otherwise I'll go through my solution now. To begin with, we'll put our end terms on. So we've got y to the 4 and we've got 3 to the 4. Next, we'll put in the binomial coefficients. We've got power 4, so we want the fourth row, 0, 1, 2, 3, 4. So we want 1, 4, 6, 4, 1. We have a 1. We need 4, 6, 4. We already have a 1 there. Next, we'll put in our powers of y. We've got 4 and then 3. 2 and 1. Then we'll put in our powers of 3. We've got 0, 1, 2, 3, and then we just simplify. 4 times 3 is 12. 6 times 9 is 54. 4 times 27 is 108. And 3 to the power 4 is 81.